Okay. So, everyone, please download this PDF, right? Like from the CTF, right? The CTF platform. Task zero, download the PDF. So this will be like the sort of worksheet that we're going to be following to inspect and explore the file together, right? So this is going to be a hopefully fun walkthrough that you guys can do together and learn along the way. Okay, um, let me try and catch everyone's attention. Okay, awesome. So, uh, no, it's fine. Okay. Anyways, so forensics, right? We're gonna start with forensics first, right? Before we continue on with any reverse engineering, because even if you do reverse engineering and you're like, oh, the program is doing this, right? If you see it runs a certain set of commands or it goes to a certain set of folders, if you don't know what's going on in those folders or what those commands are doing, then you just don't know what's going on, lah, right? So remember that when we're talking about viruses, right? What actual malicious actions can be performed on a computer once you manage to make it in, right? If you guys remember from the morning, what are some things that computer viruses tend to do? Delete files. Steal information. Give me two more examples. Y'all can pull out two more examples. DDoSing, sure.
Spreading the malware to other computers.
Spread to other computers, sure. Privilege escalation, yeah, tangential, right? Okay. So the two things that we want to look at of importance now are persistence and info stealing. So persistence is the act of staying on the computer, sticking onto the computer. Because okay, you got the guy to run your virus, awesome, right? But like, if the virus is just gonna get deleted or it's not gonna run again, then it doesn't. That's not great, you know. If you have a remote access Trojan, you want to be able to remotely access the person's computer from time to time, so it has to persist on the computer, right? Then info stealing. How much data can you steal from someone, right? Right. So this is why this specific section requires this disclaimer, right? So a lot of the things we're going to cover from here on out, right, are used in legitimate context for digital forensics. So like let's say the police or like a investigative agency, right? If they need to check what has happened to a device, they will perform what's called digital forensics, right? This is very important for things like incident response. So if a company gets hacked, we need to understand how they got hacked so that we can either set up mitigations or set up defenses for them, right? However, all of the things that we're going to learn can be used for malicious purposes, of course, right? We're going to be seeing how people steal chat history or how they might steal passwords, right? Obviously, you do not go to your friend's computer and then you apply what you've learned here, right? If you kena, you go to jail, right? This is serious, right? There are many laws in Singapore that make very strong points about doing things like this. So never apply like security related things that you've learned to devices that you do not have consent to touch. Even if you're saying, oh, I want to see if it's secure or not. If you find out it's insecure and then you tell them, oh yeah, we found out your program is insecure by hacking into it without your consent, right? You can go to jail. So like,
I mean, sure, why not? As long as you have the app. I don't know. That one really depends on like what are you hacking about your own device? Well, okay, do you want to go into tangent right now? No.
yeah, so either way, the things that we're covering today, right, they are good for you to know. They are good in a security context. Do not apply them to your own personal vendettas. Okay. So let's first look at persistence, right? Maintaining access to a system, hiding malware on the system, right? Marking targets. So like if someone is already infected, you don't want to reinfect them usually, or running malware automatically without further intervention, right? These are all things that concern themselves for persistence. And then info stealing. So this is what I opened for you guys to answer just now, right? A few targets: browser cache, browser cookies, browser logins, passwords, accounts, chat logs, licenses, personal files, right? So these are all things that info stealers might concern themselves with. So now you guys have all downloaded the E01 file, right? And you guys should have FTK Imager also. So FTK Imager is the program that we're going to be using to actually open the E01 file. So what an E01 file is, it's an evidence file. So what it is we've taken a whole Windows file system and we've packaged it in a way so that you can mount it and read it without needing access to someone else's computer. So can everyone open FTK Imager? Right.
Wait, you want to make sure that they are following.
So assuming FTK Imager is open and installed for you all, right? Just go over to File. Yeah. Go over to File and then add evidence item. Then we can do image file. Okay. Again. File. Everyone go File. Add evidence item. Then image file.
Why do you want to show up? Why do you want to
Okay, then next. Then you select the E01 that you've downloaded. And then press finish. So if you manage to import it, right? Okay, if you manage to import it, everyone should be able to see this show up on their screen now. Y.YCEP E01 inside FTK Imager itself, right? Then you should be able to press the small like plus icon and then you can start to open up the file system. So the Windows file system, right? So most of the people in this room are using Windows, and Windows comes with a very standardized layout for programs. So your system files, your program files, all occupy very specific folders, right? And this is basically universal across all Windows installations. For example, right, doing some recon on the programs that are installed. So we can't do this on the disk that's been given to us. Why? Because we actually got rid of all the folders that I wanted to look at, glup, right? You see over here, right? I mean, you can see program data, and from program data, you can see some of the stuff that might be installed onto the computer. So you do see like Mozilla, OneDrive, right? And if you go here in app data, you can also see Discord, Microsoft, Mozilla, right? So traditionally on a computer, on a Windows computer, so I'm just going to open my Explorer actually. Your programs are all installed into program files. So everyone should actually be familiar with this. Like this is pretty basic computer literacy, surprisingly enough, right? Most of your programs will install their files into program files. So these are all the stuff that's been installed onto my computer, right? Or program files bracket x86. These are 32-bit versions of those programs. So that's just at a basic glance, right? If you get someone's file system, how you can see what programs they have installed. Because you're not going to go into Windows and then search like programs and see what's there. You can see it from the folders themselves. So we're going to be looking at some very specific things, right? And we're going to follow the worksheet alongside that, right? So first and foremost, first question from the worksheet. Based off the image file, like based off the image disk, what is the username of the main account? Can someone sound it off? So like if you just open an FTK and then you just stare really hard at the file structure, right? What is the username of the main user?
Is it your computer name? Or
No. You can get it just by looking at the folders.
open?
The username of the main user.
Open.
No.
SN6.
SN6. Yes, correct. So what is quite standard on all Windows installations, right, is that if you go from C to users, you can see all the users that are on the computer, right? Every computer will come with a default and a public folder, but the main user will usually be the next one that you see. So like over here, this is my computer, right? So that's my username. But on the disk image file that you guys are analyzing, if we go over to users, we see default, public, and SN6. So SN6 is the username of the account here, right? So I don't know how you guys are gonna fill out this PDF, but that's question 1, right? So question 2, right? Inside the home directory, so now that we know the username, what sort of important files can we see? So some common places that people store information on their computers, right? In their documents folder, in their downloads folder, right? On their OneDrive, and then on OneDrive you can see, oh, there's files, there's desktop documents, pictures. On the desktop you can see they've got Firefox, they've got a PNG file, right? This is an image file. And what you can do from FTK, right, is you can actually extract out files that you find in here. So for example, if we go to documents, we can see in documents there's employment contract, right? Then what you can do is you can right click and you can export files. So this will let you export the file to a folder. So let me just export it to I need to find the folder that we're using for this. Right. So I'm just gonna extract it to the I.YCEP folder, my I.YCEP folder. And then if we go back to File Explorer, see, we managed to extract out the document from the evidence file. Then we can just read the document and we can see what's inside. All right. Ooh, and that's a whole bunch of personal information, you know. So now this is the more technical part, right? We're going to start talking about the registry. So let's talk about the Windows registry for a bit. Okay, so something that's very critical in Windows, right, is this thing called the registry. That's why I got you guys to install Registry Explorer just now. So the Windows registry is basically a giant database that a lot of programs on your computer use to store certain information and configurations. So for example, if you go on your computer now, right, don't open Registry Explorer, go and search for Registry Editor on your computer.
What is HP? What is HP local session on this?
You'll see later.
Yeah.
Yeah, so if you open Registry Editor, right, it should open up something like this. And you should be able to see a whole bunch of different subfolders inside here. These are all configuration information that your computer uses so that it can function properly, right? For example, HKey current user, and then under software, these are all configuration files and information that these individual programs are using. So like Chromium, you can see it's got like usage stats, the preferences, right? All sorts of data that's being stored in here. Or HKey local machine, right? This contains more software configurations and paths and whatnot, right? HKey users, there's actually a lot that you can go through here, and you can see that like some of the functions in Windows are all being managed in here. So like for example, the colors that you see on Windows, like your theme and stuff, right? Your control panel colors all store the hex, like not the hex, the RGB colors in the registry. Everyone able to understand so far or follow along? You can just think of the registry as this giant folder of different configurations, right? With subfolders, subfolders, right? And then all those configurations are things that programs use. It could be the whole system, it could be a specific program, right? So it's hierarchical, right? Hierarchical. And there has to be a root key, but most of the time we're only concerned with these few. So like the few that you can see in Reg Editor, in regedit. So we're going to inspect the registry, right? So over here, what file located in the user's home directory shows user-specific registry keys for the current user? You guys are allowed to use Google to find the answer. ntuser.dat. Okay, very good. So ntuser.dat is the file that stores your user-specific registry keys, right? And then if you just Google like NT-user DAT location, right, it will tell you that it's usually in your individual user folder. So if we go back to FTK, right, if you go to users and SN6, you'll see NT-user.dat over here, right? Similarly, if I do this on my own computer, right? So if I go to my home folder on my own computer, I should be able to see ntuser.dat as a hidden file, right? So this is all of my configurations, right? ntuser.dat over here is the configurations for the user and SN6. So we're gonna export this. We're gonna export this file. Lazy, so I'm just gonna export it to downloads. All right. See my downloads.
You can see the patience.
Yeah. So has everyone managed to export out ntuser.dat?
Yeah, you following along? Okay. Yeah? Okay or not? Okay or not? Awesome.
So the thing about ntuser.dat, right, is that on Windows by default, it is an invisible file. So you see, in Explorer, I have view and show, right? Usually it doesn't show hidden items. So if show hidden items is disabled, ntuser.dat is invisible. But if you do view, show hidden items, you should be able to see the extracted ntuser.dat. Sure. So now this is the part where we use a registry explorer now that you guys have all installed it. Alright. So registry explorer is a program that will help you to read ntuser.dat files, because just now we were using regedit to look at the registry of your own computer, but this isn't, you're extracting files from another computer, so you will need a different tool to read it. Alright, so let's open registry explorer. So once registry explorer is open, you can do file, then load Hive, right? So the ntuser.dat that you managed to pluck out, you can then import it in. So if you all manage to import it, you should see this, right, inside a registry explorer. And then you'd be able to see the different keys that are inside. So these are all keys and their values, right, and their data, like the data that's stored inside of them. Now we're going to talk about auto runs, right? So this is very critical for malware, right? Because you want your sometimes after you infect a computer, you want your computer virus to run every single time the user starts up the computer. Think about when you start up your computer, what starts up with it? For me, startup items, right? For me, when I start up my computer, Discord will open on its own, right? Because that's in my startup items, right? Maybe for you, Spotify will open on its own, or maybe OneDrive will open on its own, right? So malware wants to do the same thing, right? Okay, so what directory does Windows store startup programs for the current user? You guys are free to Google this, and someone just sound off the answer once they find it. Okay, start menu program startup. So yes, that's correct. If we go back to FTK Imager, right, we can start to traverse and find this. So this is standardized, right? Like on Windows, everyone will have their startup programs here traditionally, right? So from the SN6 home folder, we're gonna go down to app data. Yeah, we're gonna go from app data to roaming. Then Microsoft, Windows, I'm so slow. Windows, start menu, and programs, and startup. Now we're going to move on to a bit more info stealing and artifacting, right? So, as stated just now, right, most applications and software, they'll put the actual executable and the actual program inside program files, right? However, your user information and most of the configurations and other data to do with the program land in app data, right? The app data folder. So that's what we were looking at just now, right? The the app data folder helped us to find the startup programs, right? And these folders will also contain other configuration data and information for other programs. So what do I mean by this, right? I'm going to show my app data folder so that you guys can take a look, and then we can take a look at the one in FTK Imager, right? So, usually in Windows, the way that you can see your own app data folder, right, is you go into Explorer. I want everyone to try this. You go into Explorer, then you do %app data %. So this will take you to your own app data roaming folder, right? And then if you go up one level, this is the app data folder for your system, right? And then from here, you can actually see a lot of the information that your computer is storing. So for example, right, I use Firefox. So if I go to app data local, I can find Mozilla, which owns Firefox. And then I can see I can see my Firefox profiles here, right? And inside those profiles, I can also see, oh, okay, this one's empty because I don't use the default profile. Let's see what has files inside. You can see things like caches, activity stream, JSON, right? Thumbnails. Yeah, you can see snippets of things that we were looking at just now. These are thumbnails that were collected from Firefox while I was showing you guys the examples. That's actually quite freaky. I did not know that this was stored in here, right? So like if you think of, like, let's say that you're inspecting someone's computer, right? This is information that you can pull out of it. And it's all inside app data. Let's see what else is in my app data. Let's see if there's anything compromising, right? You can see other programs I have installed, right? MusicB, that's like a music program that I have. You can see a bunch of you can see album covers that I have. Oh, that's the Where's Roxy Demos album cover that I showed you guys earlier. That's in my internal cache, right? And that's part of app data. So what we're gonna do now, so like you guys can explore your own app data at your own time, right? What we're gonna do is we're gonna explore the app data of SIX now in the FTK Imager, right? So let's go back to the worksheet. The user has downloaded certain files from Firefox. Where does Firefox store cache files per profile? We saw that just now, actually, for my cache. So we know it's gonna be in app data, right? So we're gonna start by going to app data, local, Mozilla, Firefox, profiles, right? And then we have some folders here, right? This one's empty, so it's not this. Then here. Okay, do a quick Google search. I want someone to tell me what folder we should inspect to see. Cache 2. Yeah, so in the cache 2 folder, you can, yeah, the cache 2 folder will contain, well, the cache, right, of files that were downloaded or accessed by Mozilla Firefox. In this case, our second flag, right, for this challenge is visible in here. Next question, right? What file stores the browser history in Firefox? Again, feel free to Google this. Places.sqlite. Yes. Okay. So I have gotten an answer already. Right. Yes, places.sqlite. So this time round, just now we were looking at app data local, right? But instead, we are now going to look at app data roaming. So app data roaming, similarly, we can go to Mozilla, Firefox, profiles, profiles, the default profile again. Hey, wrong default. And then over here, there should be a file called places.sqlite.
Think about it.
Okay, for those who have a DB browser for SQLite installed, right, you can actually just drag and drop the SQLite database into it, and then you can view the entries inside the database. So in SQLite browser, right, in the DB browser, you can go over to browse data. So this shows you the overall structure of the database. But you actually want to read the data, you go to browse data. Next thing we're going to look at is password stores. So as we know, right, a lot of programs you can store your passwords inside. Like in Firefox, you can save your password so that you don't have to type it in every time you want to log into something, right? So most of them use pretty robust cryptographic methods to do this, right? So for example, on Microsoft, they offer this thing called DP API, right, which is the de facto standard for keeping your password safe. But for some reason, some programs continue to use their own databases, and some of them are not very good, right? Firefox in particular, right, it is secure if you set a master password. But if you forget to set a master password for your password database, anyone can extract them out. So now that we've gone through Firefox and we've used FirePWD to decrypt, right? The last thing that we want to look at is Discord artifacts. So, I mean, everyone in the room should have Discord installed, right? If not, like, how? And something that's very interesting is that nowadays, a lot of programs are written in this with this thing called Electron. So, notice that Discord has a package that runs on Mac and on Windows and on Linux, right? Very cleanly, right? And it would be really, really annoying if every single time the developers of Discord wanted to push out an update for everyone, that they would have to rewrite for Mac and rewrite for Linux and rewrite for Windows. So a way that they unified everything was by just making Discord, like the Discord application on your computer, the equivalent of a web browser, right? So actually on Discord, I don't think I can pop it, but on some of these Electron apps, you can pop developer tools the same way that you could on Chrome, right? So it's Chromium based, right? And what this means is that it uses a lot of the very common methods of storage that a lot of other Chrome based programs use. So in this case, it's called IndexedDB, right? A lot of Chrome programs use this thing called IndexedDB, and Discord similarly uses it, right? So some programs that use Electron and by extension Chrome as an underlying include Slack, WhatsApp Web, Microsoft Teams, and as mentioned, Discord, right? So first question that we want to ask, right? Since we know that Discord is using basically Chrome underneath, right? So that means tools that we use for analyzing browser caches might also work on Discord. So Discord, like many other apps, is Chromium based, so it stores artifacts in a similar manner. So where does Discord store its cached artifacts? So if we go over to app data roaming, so again back to app data roaming, right? And then we go to Discord cache, and then cache data. So in here, files that you can't directly read, right? But this is the standard format for how Chrome or Chromium, right, stores image caches. So this is gonna be, let's extract this cache data folder altogether. In Chrome Cache View, you guys can go File and select Cache Folder. And then instead of my actual cache folder, we're going to select the folder that we just extracted. So now you can see there's a whole bunch of cache to do with Discord, right? Because we opened a cache from Discord.